For our fourth lesson in Chapter 1, we're going to continue with the miscellaneous exercise. So we're just going to look at a couple more examples that pertain to questions within this exercise. So the first question we're going to look at is, what is the equation of the perpendicular bisector of? And I'm just going to give two random points A and B. I'm not going to specifically give numbers for this, but we're going to look at the procedure that we would use for this. Now, this is a construction that you actually would have done in geometry as well. And what you did is you'd have drawn two circles, keeping the radius the same for both, and then when the two circles intersect, if you draw a line through that, then that gives the perpendicular bisector. Now, the key elements of this perpendicular bisector is, first of all, this point here is the midpoint of the 2 points. So I called them A and B in the previous picture. And also this line here is perpendicular to the line AB. So the key elements for this question then are, first of all, I do need to find this midpoint, which I'll call M. So step one, find the midpoint. And then step two, we need to find the slope of this line, but to do that, first of all, we need to find the slope of AB. And then three, having found the slope of AB, we can find the slope of the perpendicular bisector by doing a negative reciprocal, because that's how we find perpendicular slopes. And then the fourth step, we can write the line, because we have all the information we need. We have a point that lies on the line, and we have the perpendicular slope. Now you've got to be very careful when you do this question. A lot of people, they do the negative reciprocal for AB, then they think, oh, I just need a point, and then they'll pick A or B. But you have to make sure that you pick point M. So use M and the negative reciprocal, and then use y minus y1 equals M x minus n1. And actually there is sort of a reminder there as well. M, although we use M for slope, M in this case is going to be reminders when we choose our point to choose the midpoint as well. So that might be an extra little reminder for you while you're doing that question. Now, second question, I haven't really found a particularly good method for answering this question. I have found a way of answering this question, so I'll show you that, and then hopefully that will suffice. But the textbook certainly doesn't give any clues on how to work out this question. Now, I'm going to start with a simpler question first. We're given 2 points at opposite corners on a square, and we've got to find the other two. Now, the thing that I know about the square is, if you draw in the diagonals, the midpoints are going to intersect at 90 degrees, and probably not very clear on my picture, but that's probably because I didn't draw a square. But this should be 90 degrees. Now, these are my 2 points, A and C, and I'm going to try and find B and D. So what I'm thinking is, if I can figure out the slope of this line, I should be able to work out the perpendicular slope, which should enable me to find B. Now, it's a little bit more in depth than that, because it's not just finding the slope, it's also finding the point that lies in that place as well. Certainly one thing that is important though is I want to find that midpoint. So I'm going to find the midpoint by doing x1 plus x2 over 2 and y1 plus y2 over 2. So 1 plus 7 is 8, divided by 2 is 4, and 4 plus 2 is 6, and divide that by 2 gives me 3. Now if I was to draw the line in for that on this picture here, then you can sort of see, and it's not a proof, but you can sort of see that 4, 3 does look like a possible midpoint for this question. Now the next thing I'm going to do is, and this is an important part of my method, is that you have to take the point with the smallest x value. So in other words, the point that's on the furthest to the left. So I'm going to use the point 1, 4, and I'm also going to use my midpoint, which is 4, 3. And from that I'm going to work out what the slope is. So y2 minus y1 over x2 minus x1. And I guess the reason I want to choose the point on the left most is to make sure that my denominator stays positive. So what I have here is a slope of negative 1 over 3. Now if I was to do the reciprocal for that, what I would have is positive 3 over 1. Now I can use that to help me figure out where my other point is then. So this means you go up 3 and across 1. So if I went up 3 from this point here, that would take me to 6. And if I went right 1 from point 4, it would give me 5. So 5, 6 is one of my points. And you can see, although once again not really a proof, you can certainly see that's at 90 degrees. Now the other point, I want to do exactly the same thing really. In fact, really what I want to do is I just want to extend this line backwards and make it exactly the same length. Now what you can see for this is actually, instead of going 3 up, I go 3 down. And instead of going 1 to the right from the midpoint, I go 1 to the left. So I can use that idea as well. So instead of going up 3, I went down 3. And instead of going 1 to the right, I went 1 to the left. And just very trivially here, you can see this is the midpoint again for the line BC, because 4 is between 3 and 5 equally, and 3 is between 0 and 6 equally. So I'm going to claim that these are my 2 points, B and C. And actually I just did the question by cheating, by actually drawing it in. And actually that does turn out to be the points. So I'm not sure that's a particularly brilliant method, but it's the best that I can come up with for this question. The one thing I have noticed is that if you were to end up with like -2/6, then don't simplify that, because we want to use this as how many squares we move up and down, and how many squares we want to move to the left and right. So if it was -2/6, don't simplify it to -1/3. Hopefully that will enable you to answer one of the questions from the miscellaneous exercise, though, if it were to come up.